we will have our last topic of Unit 2, Unit 1. So basically, we have started with a basic data pre-processing techniques. First, we have understood the definition of the data. Then we went for the data pre-processing, and then we went for the data processing. Later on, we find out the need of data pre-processing and the processing because we are collecting the data from the online platform, mostly online platform, and but particularly number of tuples are higher in number. So basically, we require certain kind of processing technique to handle all that kind of data, to store the data appropriately, and we can use that particular data as a part of resources. Then we can make the request and we can process several things like classification, clustering, then the association. So here we are trying to find out the relation between two different data elements, or they might be a similar also, means after pre-processing or the after processing we may find out that both are same or both are different. So if they are same, they will belong to a same class. If they are different, then they will be belong to the different classes or a different cluster. Then we find out the association rule where we try to find out a relation between two heterogeneous elements, and then a sequential association is also over there where we are supposed to consider the sequence of a particular activity. Later on we learned a Scala because the Spark is developed in the Scala, and it is considered as the basic unit of understanding because we are supposed to write out several codes over there, and therefore we learned Scala. We found that it is going to use a JVM, so most of the structure is very much similar to a Java. Therefore, for a compilation, we are using Scala C. For execution, we are using Scala, as we use Java C in Java for the compilation and Java for the execution. So we found that it is a static type language, but still we can use it in a dynamic way by passing the arguments using command line prompts. And also we have several kinds of classes. We can call it as a libraries, so that we are able to take the input during runtime. So basically it makes that particular language as a dynamic, but we have to create the classes and we need to make them ready for receiving the respective input. So this is a particular platform where we are supposed to write a program, and that particular program will decide how you are going to store your data on a server. Then we find out a new word that is called as a RDD, that is a resilient distributed data set. So basically we know our data is distributed across the several machines. I'm not calling it as a server, I'm calling it as a machine, and we are going to find out that particular data from a different machine, and we are getting the output as a single coherent file. Okay, so that I'm using the word coherent because they are collecting the data from a different locations. They might be related to each other or they might not be related to each other. Means at a single time I can fire a two queries and I can get a two distinct results. Now this is a complex thing that we have to make. Suppose if I ask you that, suppose I want to find out a particular person's sport record as well as the academic record. Fine, I have a one relation, that particular person ID, and using the person ID I can find out his or her academic record and the sport record. But how I'm going to retrieve that particular data where I don't have any kind of common point? So we found that we are having one technique which is known as a data mining, which is used to convert our data into the knowledge. So entire process is done for converting your data from the knowledge. So you're having several things like pre-processing, processing, then organization, transformation, then finding out useful data by using algorithms, etc. We are able to find out the intermediate data using a regression, and also we are able to find out a future data using the prediction. So based on that we are able to convert our data into the knowledge, and for all these particular things is going to be stored as the RDD. So that, for example, you are collecting the fruits will be divided according to their classes and they will be stored in a separate RDD. Now it's not like that. One class will use one RDD, That is again, you can use multiple RDD for a single class also. Now it totally depends on a server algorithm or a particular default algorithm that you are using. But it's not like that you are going to use the default algorithm. You can write your own code also. Means you can define how you are going to write or how you are going to divide your data accordingly. Now, definitely, it totally depends on the configuration of the machine. If the configuration is not supportive, then that particular activity is not going to happen. Means, for example, if I'm having a file of 15 GB and I'm trying to store that particular file into a 10 GB storage, it's not possible. I have to divide a data into a 9 GB and 6 GB or 10 GB and 5 GB accordingly, then I can store it. So definitely my server will take care of this to divide that particular data, but I can decide what to keep in 9 GB and what to keep in 6 GB. So that I need to write a program, I need to manipulate that particular code so that I will able to execute the respective code. That is called as the knowledge. Means, for example, it's not like a particular lecture or a particular commentary. If I'm able to find out my data according to my request, then I'm going to call it as a knowledge. Means, for example, suppose before starting this particular lecture, I'm using the internet resources and I want to find out today's topic, that is a Spark context. So what I will do, I will go to the Google. I will type Spark context and I will get a lots of material. I will get lots of research paper. But I will read out the definitions. If I found those are very much similar to the topic, then only I'm going to take it. So I will consider them as a knowledge. There are multiple things like a Spark, context, etc. are there. Even a Spark is a certain kind of brand is also there. I'm not interested in that. Okay, I'm only interested a Spark which is related to the Hadoop. So according to me, that is considered as a knowledge. The remaining is the information, remaining is the data, and I'm not going to consider that particular part. So I need to collect that particular knowledge, I need to distribute that particular knowledge, and whenever I fire a query about requesting something or about requesting a certain information, I should get the entire thing as a single file. Means, for example, we are having third practical where we are trying to find out a location which is having a maximum temperature as well as the minimum temperature. Now, in that particular data set, we are having columns like a location ID. So first column is a location ID. Second column is a timestamp. Third column is some arbitrary value over there. The fourth one is Tmin, which is called as a minimal temperature. And fifth one is a Tmax, that is a maximum temperature. Now you can see, suppose if I want to find out a location which is having a maximum temperature, then according to my interest, I will go into the column number or column name, location ID, and Tmax, that is a maximum temperature. I will sort that particular data in a descending order, and who is coming at the first location will be my maximum temperature. So this is my knowledge. Suppose, means I'm not going to consider Tmin over there, that is a minimum temperature. So it is just an information for me, it is just a data for me now. But suppose if I want to find out a data or a location which is having a minimal temperature, now Tmin will be considered as an important factor because it is going to store a minimum temperature. So now Tmax is a data for me and Tmin is considered as a knowledge. So I will take a location ID along with Tmin, then I will move into the ascending order now, and now first location will be taken into the consideration. Now you can see, whenever you want to find out a maximum data, you have applied a different algorithm. Like you are going to apply a maximum, find out a maximum of the record, or you want to find out, you want to sort out that particular data in a descending order so that maximum value will appear first. And in second problem, you are going to sort your data into ascending order so that minimal value will come first. So basically, you can use descending algorithm for both purposes. So in first case, whenever you want to find out a maximum data, you will go for the first record. And if you want to find out a minimal data, you will go to the last record. So this is the way that you are using a algorithm. So that particular part you have to done somewhere, and there should be a certain kind of application, or there should be a certain kind of platform which will allow you to do that particular thing. Okay, like whenever you are writing a Scala program, you are having a main function. So what is the job of the main function? It is a starting point of your program, or we will call it as an entry point of our program. If you are from computer science background, you must be knowing in a Java, you are having public static void main. So it is called as a entry point of a program. So whenever you are writing a Spark program, or whenever you want to use a Spark functionality, you need to find out the entry point of a program, and the entry point is called as Spark context. So you can see a Spark context is the entry point to any Spark functionality. Now, what is the meaning of functionality? Your algorithms. Okay, so whenever you are learning, I think it is in the second or third lecture, we have learned Spark ecosystem. Okay, means after completing that particular slide, which was related to the data pre-processing, several kinds of the algorithms and all, we came to the last few slides, and which were about a Spark ecosystem. Okay, we are calling it as a Spark ecosystem. So that what it means that a Spark is having certain kind of the functions to carry your activities, or to carry out your respective activities. Now, for example, in this particular case, like if you want to find out the future data, what you will do? You will go for the prediction. Okay, and for prediction, you require a machine learning technique. So we are having one ecosystem group that is called as a MLib, a Spark MLib, which is having a machine learning libraries. We will use those particular functions. We will use graphics if you want to draw a graph, or if you want to conclude something in a graph. If you want to find out a query SQL, then you will use Spark SQL, and so on. So what means, according to your requirement, you are going to use the tools. But before using that particular tool, you need to specify your entry point. And here, Spark context is considered as the entry point to a Spark functionality. So it creates a session. Okay, means for example, suppose if you want to see a result, or for example, suppose if you want to do a certain kind of financial transaction, what you will do, you will go into that particular banking website. You will log in with your account. Sorry. You will perform the transaction, and after completing, you will get log off from that particular account. Whenever you are logged in that particular account, till the time you logged off, the particular time interval is called as the session. It is so whatever you are performing, the bank is allowing you to do so. Later on, getting logged off, if you want to see the balance, you are not able to see the balance. You have to get logged in again, means you have to create a session, and after creating that particular session, you can just see your balance. Similarly, a Spark context is considered as the entry point of the Spark functionality, as well as it is going to work as a session for the Spark application. So whenever we are running any kind of Spark application, a driver program is going to start, and this particular driver program is going to initiate your Spark context. So basically, we are using a particular diagram. You can see this particular diagram over here. Now you can see the entire thing is related to the data flow, because you are going to make a request for the data, and you are going to process that particular request as a part of the data. So you are having a local, so you are sitting over here, you are creating the Spark context, then it will initialize the local file system, and then it will create a connection with your cluster. You're having a worker threads, so it will execute a respective code, and it will give you a respective data. So just like your client is sending the request to the server is going to process that particular request, and then server is going to send the response to a respective client. So this particular part is going to work over here. So you can see a more detailed diagram can be written like this. So it is a driver program. It is a cluster manager. So that, see, you are using the RDD, that is a resilient distributed data set. It means that you are dividing your data across the several machines. Therefore, there should be somebody who will find out the actual location of your data. And therefore, a cluster manager is going to play a role of it. Means, for example, suppose if you are having 15 bags, if you want to travel somewhere, and if you are having a 15 bags, then you have to keep one pay later where you are going to write down what you have kept in which bag. So you can have in bag number 1, I'm having my books. In bag number 2, I'm having the books which is related to a computer science. In bag number 3, I'm having a novels. In bag number 4, I'm having my clothes. In bag number 5, I'm having my functional dress, etc. So later on, you have to write a one note for that, and this particular note will work as a cluster manager. So it will define where you are supposed to proceed. Otherwise, what will happen? You have to open a bag randomly and you have to search your data, and it is going to take a time. So to save a time, a cluster manager is going to process that particular data and will your respective data over there. Now this is a way of creating the Spark context. Okay, you can see there are different kinds of parameters are over there. We have created a class PySpark.Spark context. Now it is taken as a voluntarily, so don't find out this particular code as a syntax. We will see the syntax while running a particular program, because it's going to change according to the version and whatever support that you are using. For several practicals, we are using Python. So basically, we will be using a different kinds of, means we are not supposed to write all these particular things. We are supposed to write a single line which will create a Spark context. But as a curriculum, we have to listen because we have to know all the parameters. Definitely, for requirement, we are using only 2 parameters. But as an academic part, you have to learn all parameters over here. So there are several parameters like master, app name, Spark home, PyFiles, environment, batch size, serializer, conf, gateway, JSC, and profiler CLS. Okay. Now we will see the explanation of each parameter. So the first one, master, it is the URL of the cluster that it connects to. Okay, so basically for in our case, whenever you are using a PySpark, you are creating your server at the local host. So you will be using a get localhost for this particular part. If you are using any kind of server, then you are supposed to pass the URL of that particular server. Also, if you are using a server, then you are also supposed to pass some kind of authentication file, and that can be called as a custom profiler, which is your last option. The second option is app name, which is a name of your job. Now, I told you, whenever you are creating a Spark context, you are creating a session. Okay, whenever you are creating a Spark context, you are creating the session, and whenever you are creating the session, you have to name that particular session. Because as a rule, means whenever we are going to perform all the practicals on the Colab, sorry, from practical number 3 to practical number 10, we are going to perform all the things on the Colab. So we can create only 2 sessions, or in a single file, we can create only 1 session. So basically, it depends on the processor that how much sessions that we can create. So for each session, we have to give a name so that you can end that particular session accordingly. So the app name is called as a name of your application or a name of your job. Spark Home is a Spark installation directory. Whenever you are executing your code on a console, you have to do a certain kind of configurations. Whenever you are using a PySpark, it will take the settings automatically. PyFiles. Now, there, if you require certain kind of supporting PyFiles, then you have to make it a zip, and you can send those particular files to the cluster, and then you can add by creating one more environmental variable, that is Python path. Just you are creating a path. We have to create one more user-defined path, that is a Python path. Now, when we see the practicals, we have to create a multiple user-defined paths. So this is one of the user-defined path. and you can save all your libraries in a particular folder in a zip format or in a py format. We prefer a py format, so that will be stored in a py format, .py format, and you have to give that particular location to a environment variable, and the name of that particular variable will be Python path. Environment, so it creates an environment. So worker node environment variables. Batch size, so here you are supposed to define a batch size. Here you are going to specify the objects. You can call it as a request. So it will, now there are certain kind of limitations. So number of Python objects are there which can be represented as a single Java object. For a disabling batch size, you are supposed to set value equal to 1 and 0, so that it will automatically choose 0 to any number object size over there. And -1 is used to use an unlimited batch size. So there are three values, basically 1 value and -1. So 1 for the disable, 0 which will automatically choose the number. Means, for example, if you're having for unlimited batch size. So if you are working for a dynamic program, you have to set path equal to -1 for using unlimited batch size. We need to have a serializer because everything will go as a processing. So we know in an operating system, we are having the concept thread. Okay, we can call it thread as a unit of execution. So it supports execution, and we require, means without thread we cannot execute our program. So basically we require a serializer. So what is the job of the serializer? It creates a session, or it creates a serialization for a particular activities or a particular program. Means, for example, suppose if I want to take the input, if I want to input two numbers, then I want to perform the addition, and then I have to display the output. So if it is serialized, then first the input will be taken, then processing will be done, that is the addition of two numbers, and finally it will display a output. But if the serializer is not present, then whoever is coming first will be executed. Means it will take any arbitrary random value, and then it will add the numbers. Then it will display that particular numbers, and it may take the respective output, or it may display the output, then it will take the input, and then it will process. So a serializer is required. Conf is there, so it is a certain kind of configurations which is related to set all the Spark properties. Gateway, so if you are using a certain it uses JVM as a gateway. If you want to use if you want to create a new session, or if you want to use a multiple sessions, then a JVM will be used, so that it will initialize a new JVM if required. JSC is, suppose if you are creating a new JVM, so you have to create a Spark context, so that instance will be over in a JSC. And the profiler CSS, it is a class of custom profiler that I told you. So it will just, we are using the default value. Now, as a programming part, we are using the app name and a master. So we are supposed to use only two values. So here you can see as an example, from PySpark import Spark context. So here you are creating it as a local, and this is the name of your application. So we are supposed to write only two lines to create the context. We are not supposed to write anything else. Just write two lines. One, from it is a way of importing the Spark context library. So it will create a virtualized interface, which we can call it as a Spark context or a Spark session, and then we can use that particular session. So as it is a local host, you can pass a local value over there. If you are having a server, you can pass the URL of that particular server over here, and then the name of the application. So this is one of the programs, a simple program. Now you can see here you have to define a file which you want to convert the file into the RDD. Okay, so basically this particular file will get processed, and then it will get converted into the RDD. Okay, it's not like that. Suppose you can store the same file without processing also. Then what you are supposed to do, just create the context and just upload that particular data. That is also possible. Okay, means without using any filter, you can directly upload that particular data. Now here you are processing that particular data. Here you have uploaded that particular data. We are doing the same thing. Then we go for the processing. So what will happen? So all the number of A's and all the number of B's will be collected. So this particular part will come under the map reduce programming, because here you are going to reduce the number of A's and number of B's together. So as a part now, it is the first program. So as a part, you just understand this is a simple program. It is importing the libraries, importing the file that you want to upload as a RDD, create the context, upload the file, and this is a part of the processing. Now it will differ in all programs. Okay, so what kind of processing we are doing over here? We are just calculating the number of A's and number of B's. So it will get calculated, and you can see all the classes will be created. So all A's will be collected, and here you are using the count operation to count the element. Okay, so for example, suppose if there are if A is detected 15 times, so there will be a 15 occurrences of A, including the class name, and you can count that particular class name to display the record. Now this is actually the practical number 4. So at that time we will see the exact execution, but as of now you can just understand this is the execution, and in this particular way we are going to write a program. So we know this particular definition, and we have came across this, that is called the transformation and the action. So basically in the last lecture we have learned the map reduce programming. So or the map reduce concept. So what happens in the map reduce programming, we are having two functions. One is called as the map, and the second one is called as the reduce. So mapping is going to collect and decides which class is suitable for my data, and the reduce is going to perform the activity which is based on the mapping. Similarly, in RDD, we can apply the operations in two ways. One is called as the transformation, and the second one is called as the action. Now, the transformation means you are going to convert your data to fit into a particular platform or to fit under a particular platform. Means, for example, suppose if you are having a thing which is then you are just reshaping that particular thing to fit it into a container, and in action you are going to fit according to that particular size. So virtually map function is exactly a transformation, and the reduce function is exactly the action. So here you can see the transformation. So here you are going to create a new RDD, because after reshaping, you have to create a new RDD. Now this is a new thing. Okay, means what we do whenever we want to pre-process the data, we just pre-process that particular data on the original data. We replace that particular data. Now here, for example, suppose if you have retrieved the data, that will be version 1. If you have pre-processed the data, then that will be version 2. If you have processed XYZ algorithm, that will be version 3. If you have processed ABC algorithm, that will be version 4. So each and every time you have to create a new RDD. Not only you have to create the RDD, but you can do a filtering. You can make them a group by using a certain kind of condition, and which is exactly called as the map. So these are the example of the transformation and action application. Okay, whatever things that you have decided in a transformation will be implemented in the form of action. So those particular things are applied with the RDD. So here you can see a class is defined, and we are just using a deserialization. So you can see we are having so here you can see we can create a different parallel files. So you have 8 files. So these particular files will start executing because you are using the parallelize function. So this one is the first function. So what will happen? Now the parallelize will create the RDDs. So this particular function is used to create the RDD. Now depending on the size, it will create a single RDD, or it will create up to 8 RDDs. Okay, means for example, you can create 4 RDDs which will be having 2 names in a single file. You can create 2 RDDs which will be having 4 names in a single file, or you can create a single RDD which will be having a single name, all names in the single file. So that will be also over there. Next operation is a count, which is used to count a number of elements in the RDD. So it is a processing. Now, for example, whenever you want to count a number of A's, you have to create the RDD, and a separate RDD will be there, which will have only, which will be just having the existence of A only, and then you can count that particular number to find out the exact value or the exact number. So this particular function is over there. The collect is one which is used to display the element, as we were using out.println to display the element. So here you can
Sir,
display
what
the.
is RDD?
It is a resilient distributed data set. Okay, so whenever you are creating the file, it is getting converted into the RDD, a small component which is distributed across the several machine. For example, you are having 100 records. The 100 records will be divided either equally or unequally. So that you can say particular, if you are, for example, there are 2 divisions, one which is having 60 RDDs, sorry, 60 records, and the second one is having 40 records. So it will create 2 RDD, one will be having 60 elements and the second will be having 40 elements. So using count, you can find if you are applying the count function on the first RDD, it will display a 60, and if you want to count, if you want to apply the count on the second RDD, it will display 40. Collect will display all the elements. If you apply it on the first RDD, it will display all the elements. Like you want to display all these particular elements, just use a collect statement. So words.collect will display the entire data. Now for this is the for each function that we have understood while learning the Scala. So if you want to apply a looping, by considering the element, if you want to apply the looping for considering the element, then you have to apply the for each. Now f is the condition, and this particular condition, this particular loop will be executed if your function is following that particular condition. Now for example, I'm having the numbers, let it be like I'm having the numbers from 1 to 10. So numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the count is 10. But suppose if I apply for each, and if I give a condition as an even number, then it will create a new RDD which will be having a 5 numbers. That is the only even number from that particular data. So the elements will be 2, 4, 6, 8, and 10. So the count will be 5. So here you have to apply. So this particular thing returns only those elements which meet the condition of the function inside the for each. So it will be applied for the entire function, but it will return the output only if it is meeting the respective condition. Just skipping the code because we are going to write that particular code while practical. Just understand the functions because you are supposed to write it for the 6 marks or the 5 marks. So this function may appear in your question paper, and you are supposed to write at least 5 functions to get the 5 marks. So each function will carry a 1 mark. So just remember, we're done with the count, the parallelize, then a collect, and the for each is also there, that is fourth one, and this one is a filter. So what is the job of the filter? You must be knowing the Excel, you do the filtering. So again, you are putting certain kind of condition, and you will appear the data which is satisfying that particular condition only. Means for example, I'm having the data of the MSc part 1, and if I want to just filter out the data of a student who are belonging from the data science, so what I will do, I will apply the filter on the subject. So apply the filter value will be data science, and then I will get all the student list were only having the data science. So it is almost same as a for each. Then the map is another. So here you are going to create a new RDD by applying the function. Now in the case of map, you are going to change your values. For example, suppose if I'm having the function, I will just use one notepad. Suppose if I'm having the function and I'm having the value 1, 3, 4, 7, 8. Okay, if I apply a for each or if I apply a filter, then suppose if I try to find out only even values, so it will create a new RDD with 4 and 8. Okay, but if I want to apply the function on each and every element, okay, if I want to apply the function on each and every element, then what is the option? Use map. So that a map is there, so you can see the syntax of the map function, and the preserves partitioning false, so that it's not going to create any kind of partition. But here you are supposed to write down the function. Suppose the function is x plus 1. Okay, so here I'm just writing the function x plus 1 and the value is false. So it will not create a new group, but my new RDD will be having all values plus 1. So you can see the original RDD is 1, 3, 4, 7, 8. Now 1 will be 2 because value is x plus 1. 3 will be 4. 4 will be 5. 7 will be 8. And 8 will be 9. So that you are going to apply this particular function on each and every element. What is going to happen on the for each? If a particular condition is getting satisfied, then only those elements are retried. You have to apply this particular function on each and every element, and it will create a new RDD. Okay, this is one. The next function is reduce. So now it will create a group of that particular function, and it will create it will go into that particular group. Okay, means for example, if it is an apple, if it is a fruit, x is there. If it is satisfied a condition for a class apple, then now it will be recognized as the apple. So x is reduced into apple. Okay, so this particular thing is also there, which is going to reduce, means it is returning the elements according to the class. The join, you can join two RDDs or the pair of element by putting some condition or by not putting some condition. So for that particular purpose, you have to use a join function. The cache is there. Suppose if you want to execute and if you want to use a transient storage, okay, persist RDD means you want to keep that particular RDD live for the entire execution. Then the cache is used. Once you have removed your program, once you have cleared the session, the cache is also cleared, so that you are not going to use. Now for cache, you're having a different option. They are a memory only, then a disk only, and the memory and server only. So when you're using a memory and the server only, then the data is uploaded on the server. At that time, if you're creating or if you're destroying the session, still you can use the value. But for the memory only and for the disk only, now for the disk only, you can also use that particular value which is stored as a locally. But we do not have any kind of local storage. If you have a local storage, then why you are using this particular spot? So a memory only means it's going to be there for till you complete your processing, and once your processing is done, that particular part is removed. Fine. So we have learned several functions like just we will revise. The first one is a count, which is going to count the number of elements. Second, the collect, which will display the all elements, or which will return. Okay, the technical term is return. We use it for the displaying purpose. That's why I told you the display. But technically, it will return. Okay. Now for each, it will be executed on the function which will be satisfying a certain condition. Filter will be also used for the same purpose. If you want to apply for the all with a particular function, then the map will be used. Reduce, it will be known by that particular class name. Join, to join two different RDDs. Cache, if you want to store the default, if you want to use a default storage level for storing certain kind of intermediate operations, then you can use a cache so that it will store that particular record. Now there are two types of shared variable. One is broadcast and the second one is the accumulator. Now what is the meaning of the broadcast? Broadcast variable is used to save the copy of the data across all nodes. Okay, what is the meaning of broadcast? It is going to send the data to all nodes. So whenever you are storing the copy of data across all the node, then that particular thing is called as a broadcast. So this variable, this shared variable will be called as a broadcast. For example, suppose if I'm storing the contact number of a particular student on all records, then that particular variable will be called as a broadcast variable, because a data is available in all possible node. And next part is the accumulator. So the accumulator variable are used for the aggregating the information through associative and the commutative operation. So whatever you are performing the join operation, so that will come under the accumulator. So in the case of accumulator variable, this particular variable is not present. You are going to create a new variable by using certain kind of statistical or a mathematical programming, or using certain kind of mathematical function or the statistical function, and it is going to take the value from a multiple records or the multiple fields, which will process and it will store that particular record accordingly. So the sum of value or the average of that particular value, average of the marks, and that will be stored for the each and every record. So two types of shared variable. One is a broadcast, which is going to store your data across all nodes. Now this is not going to store the data on all node, but it is a done by the certain kind of statistical operations. So you can see these are particular variables, but we are not going to use. So set is there, which is used to set the configuration property, set master. So these particular things are used to set the variables. Okay, we are going to use set master to set the master URL, set app name, so to set the application name, get to get the configuration value of the key, and set spark home. Now this is done in the previous version. We are not supposed to do that particular thing. Just use two variables. That is enough in your case. So it is just like retrieving using a get. So means we are using the set get method. So if you want to upload the data, you are using the set method. If you want to download the data, you are using the get method. So get file name, so it will return the file name. Get root directory, it will return the get root directory, etc. Fine. That is all. So just we will move to the syllabus. So this is your unit 1. So we have learned the basic things like the unified stack, the features of the stack. The web UI will be taken during the practical. The RDDs. We have seen how the Scala and programming, then the Spark context that we have seen today. In Spark ecosystem, that also we have seen in the first lecture. Then creating loading RDDs, that will be done in the practical part. The transformation actions will be has done just now. The few functions are also there, and the in last lecture we have completed the map reduce programming. Now whatever the functions are there like count, map, will come under the RDD operations and the RDD partitions. So this is all related to the unit 1. So I think that is enough for today. So if you're having any kind of the queries related to the today's session or the unit 1, you can ask. Okay. Now as we have completed the unit 1, so we will take a first class test on unit 1 on 30th October. 13th October. 13th October. Okay. So on 13th October, we will take a first class test of 25 marks, which will be based on unit 1. It will be on MCQ format. I will provide you a Google form link, and you are supposed to appear for that particular exam. There will be one more class test which will be based on unit 2, and the average will be submitted as a your whole internal evaluation. So for an internal evaluation, there will be 2 tests for the Spark. one or both will be in MCQ format. The first test will be on unit based on the unit 1, and the second test will be based on the unit 2. So after completing unit 2, we will take that particular thing. So the first test is scheduled on 13th October 2025 during lecture time. Okay, so first we will conduct the test. You will be given for the 1 hour, then we will continue our lecture. Means on 13th, around 13th October, we will start our unit 2. On 6th October, we will start our practical number 1. So the practical number 1 is related to the installation of the Spark. So, if possible, be with a laptop or be with a machine so that you can also perform the practical along with me. I will share the prerequisite files on the classroom so you can download it before our lecture. So, just it is just like we have to use one zip file, that is a Spark setup, and you need to just copy that particular setup. Just set the class path, yes, and then you can just see the execution. Once it is done, then we will perform the second practical also, that is related to our basic Spark operations. Means whatever we learn today, that will be implemented on the 6th October. So if possible, be with the laptop so that you can perform the practicals along with me. That's it from my side. So if you are having any kind of the queries, you can ask. Yes, just after getting logged off from this, I will upload all the notes, all the PPTs in the classroom. So any other queries?
Sir, attendance.
Yes, yes. First, let us solve your all queries if you're having any. If no, just be in the meeting. I will take the snapshot. Basically, I require 3 to 4 sessions for Unit 2 because it is totally based on the practical. So I think if you are done with the Spark concept, you will get the Unit 2 get completed in 3 or 4 lectures. So possibly by 30th October, or let us take safely till 10th of the November, we will complete our theory syllabus successfully, and till 30th November we may able to complete our practicals also. So before that we will have the offline session. Uh, okay. Still, as of now, I don't have any kind of your submission dates because still your date of commencement is not out. So as still it is not declared, we can't say anything because the engineering date of commencement is declared. The old course dates are also declared. It is in the month of December. So possibly before your examination, your submission will happen. So I think department will post a notice regarding to this because we don't have any right to declare a submission date. So department will guide you about that. I will guide you about the Spark journal. So after completing, yes, after let us complete the unit 2 first. Then we will take the revision of unit 1 and unit 2 together. Possibly, I want to take the revision in offline mode so that it will be better. Okay, fine. So if you are having our offline lecture will be in the month of November. Okay, I will declare the date because I need to take the permission from the department. So once I get the permission, I will declare the date. Possibly, I will declare it a week before so that you will able to adjust your schedule, and then we will have 2 to 3 days for that, so that we will meet and we will complete the practicals as well. We will have one session for the revision. Fine. So, any other queries?
Sir, actually, most of us don't get leaves on working days for offline practicals. So, would it be in blended mode?
Okay, fine. I may keep it. First, we are going to complete all the practicals in online mode itself, because your data science is in online mode, and then I will take the offline session.
Okay, so offline would be kind of a revision session for the online
Yes, yes,
practical, sir.
yes, yes,
Okay,
definitely.
that's great, sir. Thank you.
Because if possible, then you can come for the one day and you can just see all the installations and all the execution. If you feel confident that you don't require it, it is also okay, because the Spark technology practicals are so simple. Means for the examination, you can just complete your practical in first 15 minutes itself. So it's not a big deal for that. But still, if you're not belonging from the computer science, then you should at least come for the one day, so that at least you should know what to do about the settings and all. Fine. Okay. So if you don't have any other queries, let us end the meeting. We will meet on the Monday at 6 p.m. Thank you.
Sir, did you take snapshot?
Yes, yes, yes.